Okay, maybe we can start officially. We're already a little bit late, so let me welcome everyone. Thanks for joining today. And those of you who couldn't make it and who asked for recordings, thank you for your interest. Recordings will be sent later. I'm super excited about this topic because it's been debated a lot. And one of the questions that we were getting often is how RisingWave is different from Apache Pinot, which always leads to the broader discussion, how OLAP is different from streaming systems. And that has been really a topic that has been debated a lot over the last couple of months. So super excited to have Xiang Fu from StarTree, Zander Matheson from bytewax, and Yingjun Wu from RisingWave Labs today, talking about this topic. So some ground rules before we move to the actual topic. So at any time you're muted, but at any time you can ask the question in the QA tab. We will leave some time at the end for you to hear all the answers, for all of your questions to be answered. Yes, the webinar is being recorded, and the recording will be sent to anyone who asks. And if you have any issues with Zoom, like we had just a couple of minutes ago, let us know. So we can start by maybe all of you introducing briefly yourself, a couple of sentences about who you are to give people some context. We can start alphabetically. X, Y, Z.
Yeah, X, Y, Z. Yeah, X goes first. Yeah.
So X, yes.
Okay, so hi everyone. This is Xiang. So I'm a co-founder and founder of StarTree, which is a company that builds a platform as a service version kind of Apache Pinot, provide the cloud native based analytical purposes for the customers who need real-time analysis. So this is kind of the hot word everyone will be hearing for the entire discussion. So this company was founded in 2019 by the creator of Apache Pinot, which is Kishore and me. And we have been inspired by the user-facing analytics, kind of the RisingWave of that, from LinkedIn and Uber, a lot of LinkedIn and Uber use cases. And this company is trying to giving every decision makers the insights that they need to make the great choice. In terms of the product we are doing, we are pretty much doing the SaaS version of the Pinot. We are also providing an anomaly detection kind of tooling and product for the users. We are doing pretty much the SaaS based Pinot version. Yeah.
Okay, Yingjun, you're next.
Hey everyone, I'm Yingjun, and I'm currently a founder of and CEO of RisingWave Labs. And RisingWave Labs was a company, a company building the streaming processing database systems, basically a database system designed optimized for stream processing. And we founded as a company 2 years ago, and it has already been. It's RisingWave itself is an open source project, but like many other database companies or system companies, we are commercializing the open source product in the cloud. And that's what we have done. And before starting a company, I was at AWS Redshift, the data warehouse in AWS cloud. So yeah. That's about my background. Yeah.
Zander.
Hey everyone, I'm Zander. I'm the founder and CEO of bytewax. bytewax is a stream processor. It's Python, open source, stateful stream processor. So differentiating ourselves from the other two, to give a little bit of a pitch, it's for operational workloads. And I'm sure we'll talk a little bit about what that means. I come from a machine learning and data science background. The raison d'etre for bytewax, the reason it is existing today, is actually to support real-time machine learning workloads. That's why we built it, but it is generally applicable for a lot of operational processing tasks on streaming data. So yeah, I'm stoked to be here and excited to talk about real-time OLAP and stream processing and streaming databases.
Thanks, Zander. Thanks for introducing differentiator perspective, because I would like to hear from you. How do you think your products stand out? And maybe to share some typical use cases that you think your product address well. This should be like an intro to the OLAP versus streaming part. Again, can we start from Xiang?
Okay, so yeah, so from Pinot perspective, Pinot was actually built from LinkedIn, majorly like serving the use cases of LinkedIn's like the ads use cases, which is like you have a lot of data being ingested and you want to query those kind of data from real-time perspective in terms of like very low data ingestion latency and a very low query latency, right? So in terms of that, we actually have Pinot to become the there's some echo. Probably not me. Yeah, so we actually built Pinot for this kind of like internal kind of analysis, and then later on we are like we actually found out that the Pinot is actually more useful in terms of serving external user requests, which means we can actually open up a Pinot to be used to serving actually the entire LinkedIn user space, which can be like 100 million of the users. That's how kind of Apache Pinot being like the first shining in terms of the use cases. It's like who viewed my profile. So nowadays, let's say if you go to LinkedIn, you open who viewed my profile, all the page views, the numbers, those analysts are actually being powered by Pinot. So that's kind of like the where we kind of realize the huge space of this user facing analytics, and we are trying to like help our users and customers to actually achieve the ability to provide those like data insights, the real-time data insights for their users. That's kind of the major motivation for real-time OLAP. And of course, we need to make sure this system in itself is like multi-tenancy supported, right? So you want to have a very good cost-effective kind of support. So you kind of need to making sure you have all the like technology of indexing, query capability in terms of serving the functionality requirement, as well as still like the CPU memory kind of efficiency. You want to ensure you can serve like very huge load of the traffic, like thousands or even hundreds of thousands of queries per second. Those kind of like are the major use cases we're seeing.
Giovanna, I think you're muted.
I am.
Yeah.
But you knew it was your turn.
Oh, it's my turn. Okay, cool. Yeah, so yeah, Xiang will mention a lot about real-time OLAP database systems. And but for RisingWave, well, I mean, we are doing about what we're building is a streaming database. So it's more about the stream processing instead of OLAP. I mean, one of the key differentiators is that we don't really have the column store, and we do not really. I mean, we can probably support some analytical queries. You can definitely run analytical queries over row store, right? But well, it's definitely not optimized for that. But we are optimized for stream processing. So what's the difference between stream processing and OLAP database? Well, I mean, it's probably we will discuss that this topic later today. But really, but the short answer is that okay, what we're focusing on is more about okay, streaming analytics and the streaming ETL or streaming ingestion. For the first part, streaming analytics, you can think of like, okay, I want to monitor the monitor a trend or have a dashboard, right? Have an online dashboard, or want to do some fraud detections, alertings, right? For such kind of applications, the queries are typically predefined, right? but you really want to have the detect anomalies or refresh the result every time the new tuple comes in. So that's definitely falls into the streaming analytical query, where the streaming database system can support well. And second application will be streaming ETL, which means that you have so you may have Kafka, you may have multiple data sources like Kafka, right, Pulsar, Rapanda, or TB databases or microservices, right? And you really want to ingest the data from these systems and do some combination, do some transformation, do some joins, and then dump the result into your data storage systems like data warehouse, data lake, right? And RisingWave is or even messenger queues, right? And RisingWave as a streaming database system is actually essentially optimized for such kind of application, and we can do the data transformation, do the data ingestion pretty fast and pretty efficiently. And people may ask about, okay, why streaming database, right? We have already has the streaming processing systems or frameworks like Apache Samza, Apache Flink, Apache Storm, Apache, what else? Well, I mean, there are a bunch of stream processing systems. Why we need to build a streaming database? Well, I mean, it's definitely a trend because really, if you do not really have the storage, then you cannot do a lot of things. For example, you cannot store the internal data, persist the internal data, and people cannot query the internal data. So it could make the debugging or the query analytics pretty complicated. And also, as a stream processing frameworks, usually the API is not standard, right? If you use Flink or if you're using Samza or if you're using some other systems, then you have to learn their API. But for a streaming database, for us, well, I mean, it's just like, PostgreSQL, right? Postgres database system. You can do all kinds of the database, database operations like, create table, create a view, create whatever, right? Inside of RisingWave. So that's a huge differentiator between RisingWave and the other existing stream processing frameworks. Yeah, I can actually spend probably talk more about the RisingWave for another 30 minutes, but I think it's too long, right? I would like to hear to the next one. Yeah, Zander, right?
Yeah, I think what Yingjun said that's important to recognize is the predefined query. So the idea that you have some predefined logic that you're running over streaming data. I'm going to zoom out a bit and then I'll give my take. So I like to bucket real-time workloads into analytical and operational. It's like kind of a framework that's used in other types of workloads as well. So you have real-time operational workloads and you have real-time analytical workloads. And as Xiang mentioned, the analytical cases, you often have a human in the loop. And then as Yingjun mentioned, the operational use cases are kind of predefined business logic, and there's less need or requirement for a human in the loop. Maybe it's consumed downstream by a human eventually, but you can generally do quite a bit without the human in the loop. And I think that's where the bytewax and stream processors in general are best suited. So when you have operational use cases where you're trying to embed logic into a streaming context in order to make decisions in real time, or have the machines make decisions in real time. And so that's kind of why bytewax exists today, is to provide the Python community, which is largely like data science, machine learning, and data community, the ability to have an imperative interface that they understand to handle or to write business logic against streaming data. So we see use cases all that can go, well, anomaly detection is a really good one, where you can, for example, you can have anomaly detection over your IoT sensor data, or maybe it's some smoothing algorithm you're using on sensor data. Those are a couple use cases in the IoT space. There's also use cases in finance where you can make decisions based on inputs from the market and real world inputs, financial news, etc. So that's, I'll stop right there because that's my summary on bytewax and a little bit about how I think about the differentiation.
Thanks, Zander. So we already tackled this, but now I would like to hear like you guys like coming up with cases where first you feel that OLAP outperforms stream processing, and also like other use cases where stream processing beats OLAP. What would be the most typical ones?
Should we just free for all this?
Yes.
I mean, I think Xiang said, so like when you need the freshest data, you need low latency, but you also need to be able to ad hoc query it and retrieve it. And you have a high number of queries per second. That's like a very like analytical OLAP-y thing, where you know what you need to do to the data beforehand, whether for ETL or for the operational business logic. I think that's the best stream processor.
Yeah,
database / stream processor.
Yeah, agreed. I think from my side, I would like so you can tackle this problem from like the technical angle, right? So what OLAP can do, like OLAP system historically is like been trying to solving like the big data analytics, right? So you want to have like a lot of data and then you want to do analytical on top of it. So real-time kind of OLAP is just trying to add up like more on the freshness of the data side, but also trying to keep the ability of like being able to query the data longer enough, right? So if you want to have like a lot of data, let's say, you have like the revenue or like your ads impression or click for past 2 years, and you want to do some like long time aggregation, you kind of want the streaming OLAP. But if you know that you need like let's say minutes to hours to days, even to months, right? So if you have very good like snapshot or persistent kind of store, you can also use the streaming database to actually achieve this like the streaming framework. The other thing here is like how your query complexity, right? So if you want to check your query to be like more on the ad hoc side, you kind of don't know what you want to query, or your query is actually been changing a lot, which you cannot really come up with a view of the data to be like served at real time. Then technically real-time OLAP is probably like more suitable. The other side is like as I just mentioned, it's like your query span, right? So it's like if you want to do big to scale a lot of the data, then in terms of that, real-time OLAP is more or less like you have built the index, and then you can try to optimize regardless of the latency in terms of like to get the answers as fast as possible, right?
From my perspective, as I just mentioned earlier, well, I mean, for streaming processing systems, well, no matter whether it's a framework or a database, well, I mean, we can do either streaming ingestion and streaming analytics, right? For streaming ingestion, or for so-called streaming ETL, right? Well, I think it's pretty unique to streaming processing systems, because, well, I don't really think that any OLAP database systems can claim that where they can do streaming ingestion, which sounds kind of weird, right? So we can focus on the streaming analytics part. Well, in terms of streaming analytics, I would say that for the OLAP database systems, they are better optimized for answer your analytical queries, ad hoc analytical queries in just a second, or even microseconds, milliseconds, right? So that will be about the response time. They want to have a very quick response time, short response time, right? But for stream processing system, it's kind of different. You have a predefined query, and you have new table comp thing, and you really want to refresh the results, right? You really want to, what you care about is the freshness of the result. But again, well, I mean, that's totally different from the response time, right? So I would like to say that, okay, that would be the main difference for the between OLAP and the stream processing systems. In fact, well, I think OLAP delivery systems have trained to, I mean, to share some workloads from the data warehouses, because well, they are, I mean, for data warehouses like Redshift or Snowflake, they also exactly provide the same capability, right? Where they can do the, I mean, the analytics over a large amount of data, right? Huge, massive amount of data. And OLAP databases, real-time OLAP is about, okay, I can do the same thing, but I can do it more efficiently, or I can do it more within a shorter response time, right? Because I can build in DAX, I can do some optimizations, right? And I can support concurrency queries, right? So I think OLAP, that's what the trend of how the OLAP database systems will evolve. But for stream processing, I think the evolution will be still more focused on about, okay, how I can guarantee the freshness of the results, right? And well, it will also care about, okay, whether I can do better ETL for all kinds of the database systems, right? All data services, right? Because well, there's hundreds of data services or database systems like Kafka, Repanda, like Pausa, like OLTP databases, like microservices, right? There's so many systems, and you really want to have a very good, very comprehensive ETL support for those kind of the pipeline services, right? So definitely that be how a stream processing system will evolve. Yeah, that's it.
I have
any thoughts on this? Yes, go ahead.
Well, I actually I have a question for each of you. So first, with respect to streaming databases, why not replace in some instances, why not replace Kafka or Redpanda, et cetera, the storage / transport layer? Like if people can write an insert, right? I'll add some context here. I see like a streaming database as a really useful tool to build a real-time application. If you're like, say, building a bidding system, and in your application in the front end, you can like have your ORM or whatever write the inserts. And in this case, maybe I don't even need Kafka. I can have my whole. So is that like, am I off the mark there, or is this correct? That's my first one. My other question is about OLAP, and maybe I'll save it, but I'll come back to me if it's cool for the second question. I'll let Yingjun answer the first one.
Yeah, so I think I can answer first question, and I don't know your second question, but I think it's more about the OLAP data systems. So for the first question, so I don't really think that okay we can do. I mean, at the current stage, I don't know what will happen 5 years later, but we're at the current stage where streaming database probably cannot replace replace messaging queues, because for messaging queues, right, I think one of the biggest functionalities is to decouple the services. For example, you may have multiple data. You may have multiple data sources, and you also have multiple data destinations, right? So for messaging queue, it can essentially buffer the data for these sources and the destinations. And essentially, the destinations can ask the data messaging queue to replay some of the events, right? Replay from certain offsets, right? So that's most messaging queue can do. And it's highly optimized for storage. So if you're looking at for the, I mean, Kafka, Pausa, Repanda, everyone is claiming that they can do decoupled compute and storage right away, and store storage in S3 to lower the cost. And that's so basically they are optimizing for better storage. But for streaming database, well, I mean, it's more about better computation. I really want to have a comprehensive SQL support for the for stream processing. And in the meanwhile, I really want to lower the cost for computation. Why streaming database can lower the cost? It is because, well, essentially materialized view, it uses a concept called materialized view, right? Materialized view essentially caches the hold, right, or maintain the results, right, for some of the streaming workload. And essentially, the other streaming workloads can reuse the data or can reuse the storage, can reuse the data stored in the materialized view, in the current materialized view. So this kind of computation sharing can hugely save the cost, right? So yeah, again,
So
well, for now, I don't really think that's it's a right moment to include the messaging queue functionality inside of streaming database systems.
Okay. Yeah. Okay. Yeah, that answers the question. Now, my next question is about the real-time OLAP. So I generally see, and we've actually had requests from folks who are using things like Pinot. Well, I generally see there's some amount of processing required before you can put your data into the real-time OLAP, so that folks don't do crazy joins because that will obviously slow down the retrieval capabilities. Do you see a possibility where you can, so anyway, what I'm trying to say is you end up with this situation where you have like Kafka, then you have like Flink or bytewax, and then you write back to Kafka, and then you have that like really fast ingestion into the OLAP, real-time OLAP. And is there a world in which you could get rid of that requirement to do that pre-processing? Is that something you all think about, or how do you think about that?
Right. So yeah, this is actually a very good question that when we're at LinkedIn, and also I worked at Uber building the streaming like the PubSub and processing and also the OLAP systems there. So my overall observation for this streaming space is that, so first of all, when we're kind of adopting Kafka, it's more or less on the PubSub or the data storage and the serving part, which you want a cheap, low cost kind of storage solution, also high performance, right? You have like kind of majorly like one publisher, but many topic subscribers, right? So in terms of that, and also a lot of your data to be serving is more or less on the near real time kind of data. You won't say, okay, I want a topic to be like a year-long kind of retention. You probably just say, okay, 7 days should be good enough, right? So that's kind of like how you started all your streaming journey, and that's like for a short amount of data, I want it to be like very, very fast. And then it comes to like, and at that time, like everyone write their own business logics in their applications to do things. And then the thing here is like, we do have like things like Samza and Flink when we're like working at LinkedIn and Uber. We're actually having this kind of framework to build like generic, more or less, about generic stream processing engine. Like we want to have the SQL on top of these streams to make sure this stream processing is much simpler, right? And at this time, the focusing here is like my compute will just be once. Right, so I just do the stream processing once, and if my data sync is still Kafka, it's like I'm going back to write data back to Kafka for this like one publisher and the multiple topic subscription kind of model. This is actually how to say, if you think of a streaming and a batch, this is like your batch kind of ETL model. You are trying to adopt like the same kind of concept, but with the streaming technologies. In this kind of space, right? Because you have Spark, you have like Hadoop, those kind of things at this layer, and then you want to, but this kind of requirement and usage is also a must, and then you build this kind of framework, and you have this kind of big picture to place here. And now you are going to like the serving part. The serving part is actually historically it's like being there for probably 20, 30, or even 40 years, right? Database has been there for for a long time, OLAP is also there for like at least older than me. So the thing here is like people are trying to query OLAP for analytics queries, and then they try to get the insights. So you get like a good Kafka kind of consumer to make the data ingestion to be faster. And then you are thinking of like, okay, what's my purpose for OLAP? I want this thing to be very efficient in terms of answering my queries, right? So it means that I want to compute the index once, and then it can answer like 100 or 1,000 queries per second in a much like a low cost fashion, right? If you think of, if I have a Presto on top of a Kafka, say if your Kafka has infinity data retention, you can build it on top of S3 and you just query this once per month, then you pretty much there's no need for any streaming kind of processing or OLAP kind of fashion. You just put a Presto on top of Kafka, you just scan this kind of data once per month, then that's like your cost to serve your business needs is good enough. However, but if you want to do this thing like every minute or every second, or even like 100 times per second, then you need to have those like infrastructure to offset the per query based cost, right? So this is like how I'm looking at this field, and by looking at each layer, you definitely have like the cost to serve, and you have the cost of the processing or the storage itself. So it's kind of like how you are making the right choice in terms of like making your total cost to be at the level of like you can afford. And of course to answer your question is like streaming OLAP thing can definitely ingest or do all those kind of processing. It's just a matter of like the cost.
Yeah. So follow-up question. I mean, probably it's kind of I'm not sure whether you are suitable to answer the question publicly, but well, I mean, how do you think like the OLAP versus data warehouses?
Yeah. So
look, well, I mean, everyone is currently talking about data lake or lake house, right? Combining the data lake and the data warehouse, right? We have a new breed called the data lake house, right? And for Peanut or for the other OLAP database systems, then how do you see the trend?
Yeah, so from my side, I would like to say this warehouse is still like you're trying to keep all the data being like in the warehouse. And at that time, from the user perspective, it's still like, first of all, how much data ingestion, data freshness requirement you need. It still can be like, let's say in hours to like 10 minutes. That's probably like most of the warehouse can do. And then in terms of like all the queries, now it's still being to the level of the cost to serve, which means that you actually want to understand like how much, let's just translate it into the dollar value, right? So how much are you going to run a query in Snowflake to like generate a report? In terms of like, are you going to generate this report in a daily basis or in a minute basis? And now, once you are going to translate this, transfer your use case, not really transfer, it's like you have new use cases, which may asking you the questions of like, I want to say, let's say give me for LinkedIn, right? I'll ask like, give me like how many kind of let's say so for who viewed my profile, I may want to ask like how are my like viewers geolocation and distribution. So those kind of things can be happening like hundreds of thousands per second. And if you think of the dollar value of serving those kind of queries, that can actually be very huge from the warehouse perspective, which means that you actually need to build all those like fancy columnar data indexing, try to scan less data. You also need to build the index kind of thing, fast index like invert index, bitmap, or even do pre-aggregates to make sure that you can actually answer the user query fast enough, and also in a very low cost manner. In terms of the low cost manner, it also means that you probably need to actually put your data into memory, right? Into your L1 or L2 cache. That's kind of the way you think it's actually the serving cost is much higher, but the per query, the access, the dollar value of per access is much cheaper.
Yeah,
I hope that answers your question.
So essentially the question, I saw that there are another question probably for me, but for the similar question to you is that, okay, I think what Peanut will have the tier storage, right?
Yes.
So does it mean that Peanut will, will eventually evolve to data warehouse? Because well, I mean, if I can store data cheaply in Peanut, then why you need to go to data warehouse, right?
Well, for warehouse, there's a very high requirement called the query. You can serving very complex query, right? So in terms of that, you need to handle the cases that, let's say you want to do 10 way of drawings. You want to do like, you want to generate a very accurate report. You want to ensure you actually have the snapshot support. For example, if I want to run Spark on top of my data for reporting, I want to say that I actually want to ensure that for the time I submit my Spark job, I will have a consistent snapshot which I can actually run. So there are like certain requirements that real-time OLAP cannot really beat, right? For example, all the data are actually being like ingesting and modifying, and Pinot has like those like absurd kind of support. And since the data is constantly changing, so your numbers or your reports may also be like changing constantly. And meanwhile, how to say, for the users who don't have this kind of like requirement, I would like to say just to get data ingested into real-time OLAP and keep it forever, maybe work. Yeah, it's just like you just have like forever storage with some kind of index, which you actually be able to query the data forever. And yeah, as you said, probably in some, in near future or like in some time, we can actually achieve like real-time data warehouse or real-time, this kind of solutions from my perspective. That's actually also like one direction I want to try to push Pinot for, which is like I actually want to make Pinot on top of it, let's say a Kafka, but it's more or less about like being able to query Pinot of like in a much cost-effective manner.
Yeah, cool. Yeah, okay. Yeah, let me.
Should we answer some of the questions from the?
Yeah. Let me answer that question first, and then we can probably jump to the next question. Okay. So yeah, about there's a question about with tier storage feature in Kafka along with KSQL or Flink. Would you say RisingWave product can still be more wholesome and cheaper? And also, can you please comment on the TCO of OSS RisingWave from the POV of using Rust as a language? Okay, so yeah, let me give you a quick answer. Okay, so the first thing is that regarding the tier storage, okay, Kafka, Rapanda, Apollo have the tier storage, but Flink does not have that. So yeah, you can store data in Kafka, but if you want to use Flink to query the data, then in Kafka, then it's an external access, right? Which would be super expensive and probably can cost hundreds of milliseconds of latency or even seconds of latency, which can be super slow. And in terms of KSQLDB, similar things. Well, because KSQLDB is essentially a wrapper, SQL wrapper on top of KStream, and the storage is stored in Kafka. Essentially, these are they wrapped into a single system, but essentially it's still separate systems. So yeah, so the cost is still there. And in fact, well, I mean, most people move from Flink to RisingWave not because of the cost, but because of the user experience. Because, well, I mean, nobody would really want to learn some new language or new APIs, right? Think about, okay, I probably don't really want to have the time to spend to learn how to write Java API code, right? So it will be pretty painful. But for SQL, I mean, it's kind of straightforward, especially for PostgreSQL. Everyone knows Postgres, right? And everyone knows how to create a table, create a view, create a materialized view, create whatever in Postgres. So essentially, that's the #1 reason people moving from Flink to RisingWave. And in terms of the TCO, well, I mean, give you a quick answer that, okay, we have done some performance evaluation, and in some standard, we will report that later in Q2. It's probably this month or next. We have already done some experiment performance evaluation, and using the standard industry standard benchmark, RisingWave has already been 2 to 15 times faster than Flink, and essentially that's cheaper than Flink in terms of TCO, right? And well, why is that? I think we based on analysis, well, there are two main reasons. The first one is of architecture. Storing data in S3 is definitely, or in pure storage is definitely cheaper, and we do not need to maintain the same the huge storage inside of single machine, which is Flink does. Well, Flink has a RuxDB, right? Where RuxDB can only run in single machine. That would be pretty expensive. And second reason is that, okay, we have I mean the cloud. Well, also it's also about the cloud storage and tier storage. We have the external compactor. I mean, you can think like a function as a service to compact the data, and which can offload some of the bandwidth or workload, right? And the other reason in terms of Rust, essentially that's pretty interesting. I have to say that Rust saved help a lot of in terms of the saving the cost. And so, I mean, even if we implement exactly the same architecture in Rust, Flink, Flink architecture in Rust, I would say that it will save cut the cost in half. I guess we haven't done that yet, but we believe that will be super efficient because Rust is a low-level language and can be super powerful. And the most important thing is that it's not about the performance; it's also about the security, because Rust can help you to check the memory leak, whether you have the memory leak during the compilation time, not the runtime. Because if you detect the wrong things in runtime, then the system will crash, right? But but Rust detects such a thing, a memory leak, or memory or memory boundary check, well, during the compilation time, which means that if there are any risk, you will never be able to compile the system. So that's about the security part. Yeah, that may be my answer.
Okay, Yingjun.
So yeah, I
think questions coming in, but let's leave them for a little bit later.
Yeah,
I have a personal question that I'm super interested to hear your opinion on. So in the same way as people are talking about unified batch and streaming, can we witness merging of OLAP and streaming systems? Zander, go first.
Oh, this is an interesting question, because I think it's about the bounds of the data source. So I think that what we might end up with are abstractions that allow the end user to have an experience as if the systems underneath are unified. But I don't know if the systems underneath will actually be unified because of the different representations of the data. So in the end of the day, most of our users who might be listening or hear this, you mostly care about like getting the right data at the right time You don't really necessarily care about how it's implemented. So I could imagine there'll be abstraction layers that are made that sort of unify the systems underneath. But I don't know if I don't know to what extent you would start taking stream processors and using them in batch. Like today, you can use bytewax to process things in batch or against streams. It's all about how you can partition the data. So if you can, it's highly parallelizable. So if you have a data set that is, split nicely into 30 pieces, you can have one worker working on each 30 pieces, and it will handle moving data around to do the aggregates. I don't know exactly where that's going, but I expect there will be abstraction layers probably.
Follow-up question for Zander is that in bytewax, can you do both streaming and batch processing?
Bytewax, yes, you can. We're focused on stream. I mean, it's a data parallel approach. So whenever you can parallelize the data, you can potentially get accelerated compute time with bytewax. So like in the same way that essentially Flink could do the same thing, right? You can have file inputs, but there's always trade-offs.
So actually, another follow-up question is that do you use two separate engines to do batch and streaming? Because it's kind of debatable, right? For Flink, where they use the single engine, and for Spark, same thing, right? Where they use the same single engine to handle both streaming and the batch. So in bytewax, I'm not sure whether you use the same engine.
We use a single engine. So the engine is actually timely data flow. The same engine that's underneath the materialized streaming database. That's the engine we use, and it's data parallel. Could we swap those out? No. I mean, obviously yes, but like the time and cost would be quite significant. So it's not something that we're going to do today. It's an interesting thought. There's a project in the Python world called Hamilton. It's an open source project by someone named Stefan. I actually don't know if it's pronounced Stefan or Stefan, but and he started a company called Dagworks. Anyway, it's like everything kind of compiles down to running on a certain engine, and you can swap out the engine. So it creates data flows that you can either run Array, Spark, or you could put in whatever you want there. So yeah, it's interesting to think about for sure.
Anyone want to talk about this, Xiang?
Well, what I want to kind of just put a few comments here is like I actually do see like this kind of unified things happening, and I do have a feeling that from the usage perspective, since a lot of use cases has been actually converged in the sense of like batch use cases also realize they are actually getting benefit by having fresh data, and those like real-time applications also realize that I can actually better serving my customers or users if I have more historical data, which means in terms of like if you think of from like a Kafka stream processing and OLAP layer, you will actually find out that, for example, the Kafka trying to adopt peer story, trying to make the Kafka topic retention to be much longer. Meanwhile, let's say from the warehouse perspective, they have a Delta Lake, which tells you that they can do ingestion like in 5 seconds, like 5 minutes kind of like freshness, right? So you will see that this kind of things are already like try to converge in respective of like each one still has their ability of like, okay, I can serve like so many Kafka consumers, but with much longer period of the data. From the warehouse perspective, they can actually give you much fresh data to make your like analytical query or your complex logic to be like much kind of near real-time fashion. And also for the processing logic side, there has been like a lot of effort in terms of like how to unify the APIs or the abstraction layer, which I think everyone is actually currently doing is like how I can just write one SQL and it can actually run on top of my like streaming processing engine and also the batch engine, and it can process or mix like all my kind of processing workload. Similar thing for like the OLAP side, right? So the existing I was calling those things as like offline kind of the historic like OLAP. They're trying to make the data to be like more real time. How they can improve the data ingestion latency. That's kind of like they are doing. Meanwhile, from the Pinot side, the Pinot is trying to say, okay, since they're already doing everything real time, I want to extend with also with like tiered storage to lower the cost to serve, and also want to add more query capability and making sure the query performance is like outstanding. So I do say like at this each layer, everything is trying to like converge more on the unified kind of fashion. And I would like to say this is still like majorly driven by the community, by the users, by the use cases.
Yeah, I think there's like an organizational or educational thing. Like even if you can ingest the data into the data lake every 5 minutes, everything that's downstream of that has to happen within that window. So there's this like huge shift that has to happen where if you actually, everyone's going to be like, oh, I want the freshest data and I want it, now. If you actually want that, you have to be so much more thoughtful about moving things to happen in the streaming layer. Because otherwise, like let's say everyone has seen like a crazy Airflow situation where you have like all sorts of crazy queries happening downstream of that ingestion point. And so you can imagine if like that ingestion is every 5 minutes, all of those queries downstream, where sometimes you have like dependency on top of dependency on top of dependency, those all have to happen in 5 minutes. Otherwise, you're just going to get this like crazy backup situation, and maybe you'll have mixed matched latency on what actually are you seeing when you see the representation of the data at the end. So yeah, I think there's still a shift that has to happen, and it's probably underway right now.
Yeah, well, I mean, we only have 6 minutes left, but well, yeah, let me answer this question pretty quickly, and we actually have some questions in the right.
Well, questions, yeah. And we will move to the questions by participants.
That's right. Yeah. So yeah, a short answer is that okay, I do believe that okay, the unified streaming and the batch processing will happen in future, but well, probably right now, I mean, it's kind of difficult because not because of the design, but more about the implementation, because it takes time. For example, okay, I mean, we can definitely implement an OLAP engine inside of RisingWave, right? And for some other data warehouse systems, they probably can they can build index, right? Build super fast columnar storage index to accelerate query processing, right? And they can also be real time, right? But all these ideas need to be implemented in the existing systems. But implementing such kind of functionality can take a super long time. For Redshift, I mean, it takes probably 10 years, right? And for some other system, it also takes a huge amount of time. And really, yeah, so in terms of time, I think it's definitely, we still need to wait for another several years, right? And also, that's okay, if you really want to have a system that is optimized for both streaming and batch processing, you probably need to have 2 engines. Essentially, you need to have 2 separate engines. You cannot just use a single engine if you really want to pursue the fastest processing. Okay, why? Because I mean, stream processing is more about the incremental computation, while the OLAP processing is more about full scan, right? Or the full computation, right? The engines in terms of the engine it can be different. For OLAP engine, you probably need to have a vectorized engine, right? But for stream processing, vectorized engine doesn't really work because, well, I mean, yeah, vectorized means that you have to buffer. If you buffer, then it means that it will sacrifice the latency, right? So yeah, it's kind of complicated. Yeah. So yeah, that's my answer. And
you're running out of time.
Yeah, we can answer
Can you
some
just
questions
answer all
inside
these
the
questions? I will not call you out like individually, but whoever feels that they are suitable best to answer the questions. We have some. Oh, we have a lot of questions there.
I think there's one unanswered. Well, from what oh no, there's more now.
Yes.
The time series DB versus RTO real-time OLAP. Maybe Xiang, you want to take that one?
Sure. So from my perspective, so for the time series database, it's mostly focusing on the use cases of like telemetry, those use cases for like more on the kind of monitoring side, and also IoT kind of use cases. And in terms of like the multi-dimensional or this kind of like rich dimensional group by those kind of analytics, you are still trying, you'll still probably trying out the real-time OLAP or those like more complex queries. So time series database has been like optimized on, because all your data is like coming with like a timestamp, multi-dimensional of like the data, and then there are some metrics. So it's actually being very optimized on like keep the storage cost to be very low, highly compressed the data. So it can actually very good of serving like those continuous query of like, okay, I'll keep give you numbers, and you probably want to use those things for alerting and for triggering or some real-time applications. So those are actually pretty good use cases for time series database. For real-time, for real-time OLAP, as you already see from the name, is mostly for analytical purposes.
That's super helpful.
Anybody? So Yingjun, can you take Murphy's question?
How does RisingWave interact into
just super brief.
Okay, like warehouse. Yeah. I saw the question. So basically, it's more about integration parts, right? We can integrate with RisingWave for now. Can we integrate with all kinds of the data lakes and the data warehouses and OLAP database systems. For example, I think we have already had the integration with Peanut, and as well as some other OLAP databases. Because and also data lakes, we just announced the integration with Hoodie. No, sorry, Iceberg, and I think Hoodie will Hoodie integration will be released pretty soon. And we're also looking at the integration with data warehouses like Redshift and Snowflake, because those are two very popular data warehouses, right? And in terms of why they need to have such kind of integration? Because again, for this kind of systems, they usually want to have clean data, right? They usually want to. The first thing is actually they really want to have clean data. They want to do some cleaning. They want to do some transformation. They want to do some joins before ingesting data into the data lakes or data warehouses, right? That's number one. And number two is that if people really want to have real-time analytics or streaming analytics, they cannot do it inside of a data warehouse. If you really want to do real-time analytics or answer a query in short period of time, you probably need to OLAP database systems such as Peanut. But if you really want to have streaming analytics, for example, if you want to do monitoring, if you want to do fraud detection, if you want to refresh your predefined, if you want to refresh your results for your predefined queries in, let's say, seconds or minutes, right? You really want to have a specialized streaming engine, which can be RisingWave or bytewax. Yeah. So that would be my answer.
Yeah, we are out of time. Can we stay 1 more minute, 2 more minutes? Maybe just like to try first one. Anybody wants to stab the first one?
An overlap is the question the overlap between real-time OLAP and streaming databases?
Yeah.
I'll let the experts take that one.
Yeah, we kind of address that, but just if we can get gist of it for this person.
Yeah, so okay, I'll take it. So from my understanding, because I've been doing both sides, because when I was at Uber, we first try out to adopt Flink, Sequence Flink, in terms of like doing all those like streaming processing. I think right now like RisingWave and bytewax also doing the similar things, but more in more advanced kind of fashion. And again, from my side, my biggest so my biggest point here is like for the stream processing part, you can actually achieve a lot of your functionalities from the both side. For example, if you want to do like lookup, if you want to do like a window kind of aggregation or window drawing, a lot of things can be actually done from the both side. It's mostly about like your cost to serve, right? So if you have like the data in Kafka to be served by compute from the streaming engine once, and then you serve it to trigger application to query or to send API. That can be like very efficient with just the streaming engine. And if you want this data to be kept somewhere and you're constantly querying it, then that's actually the time that you want to make sure that your cost to serve the queries is like your major cost to serve fact that you want to optimize. So their functionality wise, a lot of things are actually being overlapped. It's more or less about the real use cases or what kind of the framework or kind of the product you want to build in terms of like picking the right technology or where you are going to position your product at.
Yingjun, can you make it into less than a minute?
Let me answer. I will just answer one question. Okay, the time source and the real-time OLAP versus as well as streaming database, because I think it is a pretty common question. So for time search database, I have to say that it's specialized. It's definitely a specialized database for time search data. But essentially, I have already seen a trend that many OLAP database systems have already claimed that they can do it better in faster, right? For example, I believe that the PNOT can definitely support time search data, and some others. Well, I probably will not name their product as well. They can also do this. Because why? Because for time search database, the magic is that two magics. The first one is that you want to have a specialized. If you want, you really want to, you want to do some specialization for a time search column, right? A column that have the timestamp. That's timestamp database. You want to do some optimization for that. And second magic is that you want to have some expressions, right? Operators for computing time search data. So you have these two magics, right? For OLAP database system, I think the first one is pretty straightforward. You can just treat the time search column or timestamp column as the primary column, right? And then you can do all kinds of indexings, right, for this kind of column. And second thing is more about implementation. If the OLAP database system have already implemented enough expression, then probably you don't really want to have a specialized time search database, right? And for streaming database, we can also do a similar thing. That's basically the same thing, but it's more about whether you care more about the storage part or the computation or freshness, right? If you care more about the result freshness, then go with the streaming database. But if you care more about whether I can answer the queries in a short period of time, milliseconds or sub-seconds or seconds, right? Go for the OLAP database systems. Yeah.
Okay, we need to wrap it up here. This was so much fun. Thank you so much. All unanswered questions, I will be reaching out personally and pinging you guys to help me out with the questions. Thank you so much again. Thank you for your time. Thank you for all this amazing conversation. And hope to see you soon again at one of our events.
Thank you for organizing. This was super fun. Thanks, everyone.
Thanks for organizing.
Thanks. Yeah, bye.
Thank you.